Hello students. So we move further with the numericals of mole concept. We did two numericals in lecture number 2. Lecture 1 was the introduction on mole concept and lecture 2 was two numericals which we did a lot of formulas and the various tricks to get the formulas. और अब आगे बढ़ते हैं, we do numericals further. Okay? So I am in the third numerical, question number 3. Calculate the mass. Calculate the mass of potassium chlorate. Calculate the mass of potassium chlorate required to liberate 6.72 dm cube of oxygen at STP. That's the question. Calculate the mass of potassium chlorate required to liberate 6.72 dm cube of oxygen gas at STP. We are solving in the board pattern because this I am solving the government textbook numerical, so we are going in the board pattern. The very first thing, children, is the data. In the data, we have been provided with the compound which is potassium chlorate. Formula is KClO3. Here only we will find its molar mass because definitely we will be requiring it later on. So K is 39 plus Cl is 35.5 plus 1 oxygen is 16, so 3 into 16. So that becomes 5.221 and unit is gram per mole. Then we have got volume of oxygen gas, and that's 6.72 decimeter cube. So compound is potassium chlorate, that is KClO3. And we've got molar mass, where potassium we substituted 39, chlorine is 35.5 and oxygen is 16. So 1 oxygen is 16. So 3 oxygen is 3 into 16, that is 48. When we add, we get 122.5 and the unit is gram per mole because it is the mass of 1 mole of a substance is called its molar mass. Okay, now volume of oxygen is also given and that is 6.72 dm cube. Now what I want to find is, पता क्या लगाना है हमको? पता ये लगाना है कि 6.72 dm cube of oxygen at STP अगर निकालना है तो कितना मास पोटेशियम क्लोरेट का खर्च होगा? That is what we are supposed to find. पता क्या लगाना है? पता ये लगाना है कि mass of potassium chlorate is how much? That is what we will find. So, in the formula, the very first thing we will be doing is, we will write the reaction. Calculate mass of potassium chlorate required to liberate 6.72 of oxygen at STP. So let us see KClO3, how much oxygen it can give. Standard equation, it can give me KCl plus O2. O2 is 2O, but I don't want 2O, I want 3O. So I write here 3. But 3, 2 is 6 oxygen atoms, but I just want 3 oxygen atoms, so it is 3 by 2 O2. That is 3 by 2 into 2 oxygens. So 2 cut, so 3 oxygens left. Once again I am writing here 3 by 2 O2 is nothing but 3 by 2 into 2 oxygen atoms. Since this gets cancelled, so we have 3 oxygen, so 3 oxygen getting balanced. Now children, over here, if 1 mole of potassium chlorate is giving 3 by 2 mole of oxygen molecule, then I have to find 6.72 dm cube. Oxygen will use how much KClO3? लेकिन ये डीएम क्यूब है, ये मोल है, यूनिट सेम नहीं है. सबसे पहले इसको मोल में कन्वर्ट करते हैं. सो मोल ऑफ ऑक्सीजन, तो कौन सा फॉर्मूला लगेगा? वॉल्यूम वाला. वॉल्यूम ऑफ ऑक्सीजन अपॉन जीएमबी. Why? Because it is in STP, so 6.72 upon 22.4. इसका यूनिट dm क्यूब, इसका यूनिट dm क्यूब पर मोल. सो dm क्यूब कैंसिल, तो ये कितना आ रहा है? 6.72 upon 22.4. Okay, so that's 0.3 mole. हो गया. तो ये क्वांटिटी मोल में हो गया 0.3 मोल. तो 0.3 मोल को कितना KClO3 लगेगा? Let us just see. Since 3 by 2 mole oxygen requires 1 mole KClO3, therefore 0.3 mole oxygen will require 3 into 1 upon 3 by 2, so 2 into 3, so that becomes, so 3 by 2 mole को 1 mole लगा, so इसको कितना लगेगा? 3 by 2, correct? Yes. ऊपर जाएगा, सीधा मल्टीप्लाई नहीं होगा, रेसिप्रोकल, so cut, so 0.2 mole. कुछ लोगों को ये समझ नहीं, गड़बड़ क्या किया? Let us see here. इधर छोटा सा सॉल्व कर रहे हैं. ये देखो 0.3 into 1 upon 3 by 2, तो ये ऊपर जाएगा तो 2 by 3 हुआ, correct? 0.2 mole KClO3. Now, since 1 mole KClO3 is, हमने इधर मास निकाला था 122.5 gram per mole. Therefore, 0.2 mole KClO3 equal to, so 122.5 into 0.2, 2 5s are 10, 1 2 2 4 1 5 2 2 4 2 1 2 1 2 1 2 gram. So finally what we'll do, bachcha log? We'll be writing the result. What's the result? Mass of KClO3 EU 24.5 gram. That's the way. So I hope the question is clear to you. Yep. Is it clear to you? Now we take the next question. One more we'll solve. Okay. The question is, calculate the volume of hydrogen required. I'm solving it here. Question number 4. Calculate the volume. Oh, we're going out of the boundary. Calculate the volume of hydrogen. Calculate the volume of hydrogen required for complete hydrogenation. Calculate the volume of hydrogen required for complete hydrogenation of 0.25 dm cube of ethyne at STP. So that's our question. Okay, first we need to write the data, then we'll be writing hydrogenation, and then we'll be moving ahead. So the data is very simple, and it's volume of ethyne. Ethyne is C2H2. So volume of ethyne is 0.25 dm cube. Okay, now next we are given with nothing. We have got a condition and it's STP conditions. Okay, that's fine. To find, पता लगाइए, क्या पता लगाना है? Volume of hydrogen. Okay. Now the solution, very simple. सबसे पहले लिखते हैं रिएक्शन कि C2H2 में हाइड्रोजन कितना लगता है अगर एक स्टैंडर्ड इक्वेशन बनाते हैं, ठीक है? अब हमें पता है अल्काइन्स हैव 4 हाइड्रोजन एटम्स लेस देन अल्केन्स, तो C2H2 को लगेगा 4H यानी 2H2 बनेगा C2H6। यानी अगर ये 1 वॉल्यूम है तो ये 2 वॉल्यूम है, तो ये 1 वॉल्यूम मिला। अब इधर दिया है ये 0.25 वॉल्यूम है, तो ये कितना लगेगा? very simple. So here we can consider one volume as 1 dm cube. One volume can be considered as 1 dm cube, no problem. So we can write, since 1 dm cube C2H2 requires 2 dm cube hydrogen, therefore 0.25 dm cube C2H2 requires how much? So cross multiply 0.25 into 2 upon 1, that is equal to 0.5 into 2 है, इधर दिख रहा है, नहीं दिख रहा है, okay, let me bring it here, 0.25 into 2 upon 1, so that is 0.50 cube, okay, so we write the result, and the result is volume of hydrogen is 0.5 dm cube. That's the way. Okay, students? So this much is clear to everyone. Now I'm moving to the next set of questions. We've done 4 questions. We do little more. I'm moving to that little more. Let us see the next. I just erase this. So one more round of numericals, at least we do 2 more. Okay. So the next question. Here we go. Calculate number of moles. Question number 5. Calculate number of moles. Calculate number of moles and molecules of ammonia. Calculate number of moles and molecules of ammonia present in 5.6 dm cube of its volume, present in 5.6 dm cube of its volume at STP. So very simple question. So the first thing, data. What's the data, beta? The data is volume of ammonia, and that is equal to 5.6 dm cube at STP. Okay. अब फाइंड क्या करना है हमें? टू फाइंड, अब अमोनिया इधर मोलार मास निकाल लेते, वी मे नीड इट. मोलर मास ऑफ अमोनिया, नाइट्रोजन 14, hydrogen 3 in 1, so that becomes 17 gram per mole. What about gram molar volume of ammonia? Obviously 22.4 dm cube at STP. इतना हो गया. Okay? So these many things we already know. Now let us proceed further to find. क्या पता लगाना है? दो चीज, एक number of moles और दूसरा number of molecules. ठीक है? Solution. Number of moles का formula n will be, कौन सा formula ले? हमें volume दिया है, volume of ammonia upon gram molar volume, GMV, of ammonia. So that becomes 5.6 dm cube upon 22.4 dm cube per mole, liter per mole. So n is how much? What will be the calculation? We have 0.25 mole. Okay, so we got moles of ammonia. अब ये moles को convert करना है molecules में. A हो गया solve. So this is the answer of first part, A. Now B. Number of molecules is number of molecule into atomicity. Yeah? Someone said atomicity. I wrote, nahi, atomicity nahi hai. Number of molecules is equal to number of mole molecules into yes, Suhani. Number of mole molecule into Avogadro's number. Number of mole molecule कितना है? 0.25. Avogadro's number is 6.022 into 10 raised to 23. So multiply and get the answer. I think that you can do. It comes on 1.505 something. Just check it out on your own. Multiplication you can do. So that's the way to solve this one. Now we take one more question. Question number 6. And once we do that, you'll be able to solve rest of the worksheet. Then we will be taking in the next lecture a little bit difficult numericals of, I'll teach you the JEE and NEET level theory. We're just doing board pattern 11 standard pattern. Now right now we are doing nothing much. Then we go to the higher level slowly. Now the question is, calculate number of atoms of hydrogen. Calculate number of atoms. अब जैसे यही सवाल में होता नंबर ऑफ एटम्स इन अमोनिया, तो अमोनिया में नंबर ऑफ एटम्स है ये 3 + 1 4, तो इतने में कितना होता है, इसको 4 से मल्टीप्लाई कर देते हैं तो नंबर ऑफ एटम्स मिल जाते हैं। तो अभी सवाल कुछ वैसा ही है, कैलकुलेट नंबर ऑफ एटम्स ऑफ हाइड्रोजन, नाइट्रोजन, कार्बन, ऑक्सीजन present in, okay, present in, yeah, let me just see the question. Present in 5.6 gram of urea. Present in 5.6 gram of urea. Okay. Now the very first thing, data. Data में बहुत कम दिया हुआ है. Only we have been provided with mass of urea. So mass of urea is 5.6 gram, children. Children, mass of urea is 5.6 gram. Okay. Now to find. Yeah, we can do one thing here. We can find molar mass of urea. Molar mass we can find, and that will be urea का formula पता है किसी को? नट्टू. तो ये 2, 14, 12, 16, 14 and again 2. So this is 60 gram per mole. ये भी निकाल लिया हमने. आगे we may need it. We may need it further. Let's just see. Obviously, we'll need it क्योंकि मोल निकालने के लिए मास है. So we have mass upon molar mass is mole. मास दिया हुआ है. मोल हमने मास दिया हुआ है. मोलर मास हमने निकाल लिया. We can find mole. Now to find number of atoms, not molecules. Number of atoms of HNCO. Okay. Solution. सबसे पहले मोल निकालते हैं. Okay, number of mole of urea. So mass of urea upon molar mass of urea. So ये हो गया 5.6 upon 60. 5.6 upon 60. That will be how much? यूनिट भी डाल देते हैं. ये ग्राम है, ये ग्राम पर मोल है. ग्राम कट 0.09333 mole. So we got number of moles of urea. Now I want to find number of atoms of hydrogen. So what we'll do is something very, very simple. Number of mole of urea into atomicity of hydrogen in it into Avogadro's number. So number of mole of urea is 0.0933 into कितने hydrogen है 2 + 2 4 into 6.022 into 10 raised to 23. You can multiply and write the answer. You can multiply and write the answer. Do you need my help? Yep. Okay, one I will tell, rest I will not tell the answers. will be 2.24 into 10 raised to 23 atoms of hydrogen. Okay? Exactly same way, number of atoms of nitrogen. How? Number of atoms for nitrogen will be number of moles of urea into atomicity किसका? Obviously nitrogen का into Avogadro's number. Urea moles will not change. 0.0933 into कितने atom है nitrogen के? 2 into 6.02 into 10 raised to 23. Find the answer on your own. Similarly, number of atoms of carbon is equal to 0.0933 into atomicity carbon का कितना है? 1 into 6.022 into 10 raised to 23. You can find the answer. Similarly, number of atoms of oxygen. You want me to tell the answer? Some people are looking at me. Do you want the answer? No, I will not give the answer. Find it on your own. 0.09. So 0.0933 into 1 into 6.02 into 10 raised to 23. Correct? You can find the answer on your own. Find the answer on your own. Okay? चलो ठीक है, एक लास्ट आंसर सोचते हैं, बता दें. This will be one more I'll tell. 50-50. 50 I did 50. 562 into 10 raised to 23 atoms of oxygen. जैसे मैंने ये आंसर बताया, मैंने 2 नहीं, मैंने 3 आंसर बता दिए. खोपड़ी लगाओ कैसे. Anyway, so this was the numerical on mole. I think we did 3rd, 4th, 5th and 6th today. And all the best to you. Love and blessings to all of you. We meet soon.